All right, so graphing notes, talk about line graphs. Okay, first of all, when we do experiments and whatnot and we collect data, there's usually some kind of dependent variable and some kind of independent variable. What is the difference? Good question. Another way of saying this is responding variable for dependent. And for independent, we say manipulated variable. And a lot of times I actually prefer to use these because they explain things a little bit better for an experiment. So when we do an experiment, there are these things called controls that we have for all the groups. We have a control group, which is normally like normal conditions. And everything else, everything between groups that is the same, we call constants. All right, so there's a little introduction to some things. All right, so those variables I was talking about. The manipulated variable is something you change on purpose to test. I'll say changed by tester, the person doing the test, okay, doing the experiment. You change something on purpose. Okay, so let's say I want to do a test. I'm driving further to school now because I moved to Royal Oak, so I have a long ride to school. I have a couple different routes I can take. I can go 696 west to 275 south. I can go Southfield Freeway down to 96 west to 275. So I have a couple different routes I can take to get to school. All right, so I want to do a test. I want to find out which of those ways is the best. So what I'm going to do is I'm going to change something about my coming to school. And that thing that I'm changing in this example would be the route that I take. Okay, so one day I'm going to time myself to see how long it takes going 696 to 275 down to Michigan Ave to school. The next day I'm going to test myself going down Southfield to 96 to 275 down Michigan Ave. All right. So as a result of me changing my route, there's probably going to be something else that changes because of that. What do you think is going to change because of my route? It's going to be different because of my route. Any ideas? Emmett? The amount of time it takes, right? So the amount of time it takes to get to school is a result of which route I'm taking to get to school. So we call that a responding variable. Okay? Responding variable. Okay? Changes because of the manipulated variable. And I'm going to shorten it a little bit. Cool. Changes because of the manipulated variable. Huh? What's wrong? So the reason why I'm going over these is because when we make a line graph, we are going to have two axes or axes, axes. And the one that runs left and right is called the x-axis. And the one that goes up and down is the y-axis. You can remember that by y, like yo-yo. A yo-yo goes up and down. Okay. All right. So the reason why manipulated and responding variables are important is because we're going to put the manipulated variable always on the x-axis. the thing that we're changing on purpose. We're going to put on the manipulated variable. Now, the example I gave you guys about routes to school would not be a good one to do with this type of graph. Line graphs are used more to show trends or patterns in data. If I was just comparing two routes, any idea what kind of graph I should use if I'm comparing two things or more? We would do a bar graph. Yes, bar graph. Okay, but we're going to be doing line graphs. We're going to be looking for trends or patterns in data. So if the manipulated variable goes on the x-axis, we're going to be putting the responding variable on the y. All right? Okay, so when we do these, we always want to make sure that we put a title on our graph. Okay. And so basically we look at what value we have for the manipulated variable we come across to, and we find the spot on the y-axis where that data point will match up, and we'll make dots. Okay? I'm going to take that one away. I'm going to do something else. So maybe we've got a dot here, maybe 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 a dot here. Okay? So one thing I wanted to show you guys is a best fit line. We're going to be doing best fit lines. So with best fit lines, okay, we're going to look at the general pattern of our data. All right? Look at the pattern of our data, and we're going to try to make a line that kind of gives us an accurate representation of what the data is showing. All right? And we're going to basically be drawing a line right through the middle of our data points. Rather than connecting them up and down, line through middle of data points. All right. When I make this line, okay, if I take away the outliers and just look at my good data, I should make the best fit line so that there are equal points on each side, equal number of points on each side. So if I have that data like I have up in the graph, and I look at this, I see that the data seems to be kind of following this path here. All right. So what I would probably do if I had my graph in front of me, I might take a ruler, I might lay it down there, I might see, do I have 3 data points on each side? Because there's 6. Yep, that seems to work. And that would be my best fit line. Okie dokie. Okay, dokie. And that's pretty much it, except for one thing. We might want to find the slope of this line. All right? What is the slope of this line? So if we look at our x values and our y values, you might have heard slope as rise over run. Oops, I put rise run. Rise over run. Sorry. All right, which really means what we're going to be doing is we're going to be looking at the difference between 2 points on the line. And we're going to take a look at, say, the second data point's y value, so maybe y2. And we're going to subtract the other y value, y1. Okay, so what's the difference between the two data points in terms of the y values? Take the second point's y value, subtract the first point's y value. All right, and if I look at the run, that's actually going to be the second point's x value minus the first point's x value. So if I take the second point's y value and subtract the first point's y value and divide that number by the second point's x value minus the second point's x value, then I would get rise over run, which is our slope, okay? And if we get positive, it's going uphill. And if we get negative, that means it's going downhill. Okay? Now, in terms of making scale, so we got to pay attention to scale. What I want to try to do, scale and range, is I want to try to figure out a way that I can make my data points easy to see, so not shrunk down, but at the same time, use as much of the graph as possible. I want to use as much of the graph as possible. Okay, so I got to take a look at the range of data. So the range is going to be if I take basically what's the difference from my highest value to lowest. What's the range? How many data points do I have to set up here? Usually we start with range when we're doing graphing, we'll start with 0. Okay? So let's say I have some data points. I have one data point is 11, another data point is at maybe has an x value of 25, and another point has an x value of 50. Okay, that tells me that the range is 50. I have to go up to 50. All right, and then what I would do is I would make an even number of marks depending on how much space I have. But here's my graph, and let's say I have 5 marks on it. Okay, I can make 5 marks. And the data I just gave you, I said, what I said? Let's say it's 12 for the x value. And then say we have, I'm making new numbers, but it doesn't matter. So here's my 3x values that I have to plot here. So I'm trying to figure out what kind of scale now, okay? So I said that I have to go, if I start at 0, and I have to go up to 50 at least, okay? You might want to go a little beyond, depending on how it works out. But in this scenario, if I have 5 marks and my highest mark is 50, then I can make each of these 10. I'll just say, okay, I got to cover 50 data points. I have 5 marks, so I should make each one worth 10, and I should be okay. So 10, 20, 30, 40, and 50. And now I'll be able to cover all my x values, and I'll be using a large part of the graph. I'll be using all of it on the x-axis, okay? Maybe it's the same thing on the y-axis for my responding variable. Okay? Now, on the responding variable side, the y-axis, maybe my values are these. I've got y equals 15, y equals 64, and y equals 87. Okay? So On the y values, my range is going to be, I need to cover up to 87 at the highest point. Okay? So again, I have 5 marks. If I took 87 and divided by 5, what do I get? I would get 1, 7, and some change. Okay, 17 point something. All right, now 17 is not a really cool number to use for each mark. Let's go by 17s. Or in this case, if I went by 17s, it wouldn't be enough. Let's go by 18s. Okay, if I went 18, it's going to go a little bit too high. Now, a little bit too high, going a little bit too far, that's okay. What you can't do, though, is not go far enough. But 18 is still not a real cool number to use for each mark. 18, 36, what comes next? All right, 54, is that right? What about if we just kind of bump it up a little more and go to 20? Would that be cool? Let's see. 20, 40, 60, 80, 100. Am I still going to use most of that y-axis? Yes, I am. Okay. Now, would it have been a good idea to make those by 50? No. I would have had room to fit them all on the graph, but then my graph's going to be shrunk down. It's going to be smaller than it needs to be. Okay? So that's how we make the scale, determine the scale. We look at the range, how many data points do we need to cover, and then we look at the scale. Always make sure that there's a title. If you had more than one graph, like sometimes they put 2 line graphs on one, then you want to make sure that we do different patterns. Okay, this is not the kind of line graph we're doing. Oh, you can't tell that one apart. All right. So maybe my other graph, I got to do something else. Okay. Now in this case where I have 2 different things, what would I have to make for this graph? A key, right. You guys are familiar with that. A key, which means here in Spanish. All right, so any questions about that at all? Good? Good? All right, that's the end of the notes.